Good afternoon, everyone, and welcome. Today we're going to be discussing the pros and cons of 3D modeling paradigms, direct modeling, and history-based modeling. We want to give a shout out to our sponsor today, PTC. Before we start, let's go through a few housekeeping items. The audio of this webinar, as well as the slides, will be offered to everyone who's registered via email within a few days of the broadcast. Go ahead and type in questions as we go, but we will hold the Q&A to the end of the presentation. And if you'd like to tweet out during this webinar, the hashtag is #DWWebinar. I am Barb Schmitz. I'm a senior editor at didn′t, covering the CAD space. Our first speaker today is Chad Jackson. He's the principal analyst of Lifecycle Insights and a recognized authority on technologies that enable engineering, including CAD, simulation, PDM, and PLM. Due to his technical knowledge, thought leadership, and more than 20 years in the industry, Chad is a sought-after expert, author, speaker that has advised, published, and presented dozens of times, both domestically and internationally. Chad, take it away.
Great. Thank you, Barb. And thanks for inviting me to come on and present today during this webinar. This is an important topic. There's been a lot of changes in the industry over the last 5 to 10 years, and it's important to look at how these technologies fit into activities during the design phase. So let me start there and kind of set a baseline for the rest of the conversation. So when we're talking about direct modeling and history-based modeling, it's important to understand, well, what is the user trying to do? And up on this slide, you can see 4 different possibilities. Now, you'll notice there's a distinction between designing products and actually documenting those products. You know, one is all about creating documentation that can be used downstream. The other activity is about exploring and iterating on a design so that you can meet the requirements for the product. Obviously, simulating a product's performance is also important. There's lots of abstractions and simplifications that need to be done in that scenario. And also, when you produce a product, when you go to manufacturing, whether you're creating CMM toolpaths or you're creating tool and die or you're creating NC sequences, you need to be able to modify excuse me, the product or part so it can be manufactured. Today, we're really going to be focusing on designing products and documenting products. So just to let you know, the focus is a little bit more narrow here. Next, let's talk about the different phases of the product development process where these tools can be used. This looks at the critical path. So you can use modeling tools obviously in concept design, detailed design, and manufacturing prep and execution. It's important, though, to understand the difference between these different phases and when they start and when they end. Excuse me. So concept design really starts, or really ends, I'll say, when you get a financial commitment, either from a customer to produce and deliver a product, or you have formal approval from executives and you have funding behind the project. Excuse me. That's the kind of transition point from concept design over to detailed design. And that's when you have formal resources that can be applied to the development effort. The detailed design effort continues on until you hit design release, upon which engineering releases the documentation to manufacturing. And then obviously they can use those deliverables to produce the product. Today we're really going to be focusing on concept design and detailed design. Now, it's also important to understand what are the differences between these 2 different modeling paradigms. Let's start with the history-based one first. With this one, you're creating geometry, 3D geometry, through features, although you can think of it as operations as well. These can be sketch-based. They can manipulate edges like chamfers and rounds, and obviously they include other more complex geometry like sweeps and blends and things like that. Now, the operations that are used to create that geometry, features, as some people call them, are persisted or remembered. So you have a history of how they're built in sequence. That also creates interdependencies between those features. So if you use a surface and you're building a sketch on it and then you extrude off of that, well, that resulting extrusion is dependent on that surface on which the sketch lies. Now, changes to that geometry also relies on those initial definitions that were used to create the geometry. And that's an important aspect, especially when we start to compare and contrast it with direct modeling. And let's take a look at that next. With direct modeling, the geometry is either created through operations, very similar to features, but the history is not persisted, or it's not remembered. It's kind of forgotten. And it's almost like you're dealing with an imported piece of geometry where there's a boundary representation, but how that geometry was initially created isn't remembered. Now, you can select geometry and directly manipulate it. You can push it, you can pull it, you can use some parametric control for that. But again, the history is not preserved, but also, what's also very important, you can change the geometry in ways that are different from how that geometry was originally created. So you're not constrained in that regard. Now, as a last note, I think it's also important to point out that in this conversation, we're not just talking about 3D geometry. There's a parallel with 2D geometry as well. Sketcher tools let you draw out entity by entity what a 2D section might look like that you can use in lots of different ways. Constraints are used to kind of control that 2D geometry. It might be parallelism, perpendicularism, concentricity, lots of controls like that. Drafting tools are very much like a direct modeling type of approach. You create the entities, and there might not be any constraints controlling exactly the behavior of that 2D geometry. So there is a parallel from the 3D world into the 2D world. So with that, that's it for my slides. I'll join you back again in the Q&A, and with this, I'd like to hand it off to Brian. Thanks.
All right, great. Thank you so much, Chad. That was a great overview. Next up, we have Brian Thompson. He is Vice President of Creo Product Management at PTC. Brian has over 15 years of experience in product development in a variety of discrete manufacturing industries. Brian holds 6 product design patents, many of which are on products still being sold today. He has worked in a variety of roles in PTC's customer base, such as engineering management, product development management, and technical product management. All right, Brian. Brian's going to cover concept design today.
Okay, great. Thanks a lot, Barb. Can you hear me well? Okay, excellent.
Sure can.
So I really like Chad's introduction because it lays a really great groundwork, and I think there's a lot of acceptance out there in the marketplace that different paradigms other than history-based parametric modeling might be better suited for concept design. And in fact, some work that we've done in the last 3-4 years surveying our customers and understanding what they're looking for in the concept phase has certainly borne that out. So that's what I'm going to talk about today. When we researched this, what we found was that customers wanted to make more of their timing in the concept design phase. They wanted to be able to evaluate more concepts in that same amount of time. And in fact, 92% of them said that they would benefit tremendously by doing that. Makes sense, right? The possibility of being more successful with your product grows if you can evaluate more concepts early in the design process and choose one that's more ideal through that. At the same time, there's a speed and flexibility component required there because you're evaluating concepts. You're not caring about, thinking about the history that Chad talked about that gets built up in a parametric model. But at the same time, we found out customers are not using 3D modeling tools. And why is that? Is it because the direct modeling tools hadn't gained enough notoriety back when we did this survey in 2011. Not sure, but we had a lot of customers looking for speed and flexibility, but also saying that they're not using 3D. So that's something to think about as we go forward in this discussion. We're also seeing that customers are looking to make sure that whatever data they create in the concept phase is actually reusable. They don't want to recreate data as part of the process of moving from concept into the design phase. And over 60% of our customers said they were having this problem. They're having trouble recreating or spending time recreating information created in the concept phase in the detailed design phase. And interesting about this particular metric is this was really speaking to the 2D problem that Chad ended his discussion with. So I think that's an interesting parallel there. And then last but not least, in terms of metrics, they really want to be able to reuse a lot of their existing data. So they're duplicating effort, they're redesigning things when they try to reuse their existing data, and they're motivated to do that because a lot of the customers that we surveyed, they're doing evolutionary designs. They're not recreating designs from scratch or creating new designs completely from scratch. They want to evolve new designs, but again, going back to the previous slide, they want the speed and flexibility that may not be there with a really locked down parametric model. They want some capabilities there that are just not available. So thinking about these metrics that we got from this survey and kind of laying them out and looking at different direct modeling technologies and how they might be useful in the concept phase. I just have a way to think about it here that with some of these metrics repeated here to just give the audience something to think about. You know, concept design can be thought of initially as doing industrial design, like ergonomically shaped products. And as we dug into this deeper with customers and thought about their feedback, what we found they wanted from us is they wanted better tools for doing industrial design that had much more efficiency and a much simpler paradigm than traditional surfacing tools that are used in a history-based parametric modeling environment, like the tools wherein you would build all the curves to match the edges of this mouse, and then from those curves build the surfaces and control the patch structure in detail. Customers wanted a much simpler paradigm to be able to do industrial design work, get their job done more efficiently, evaluate more concepts in the concept phase, as I discussed earlier, but they wanted to reuse those free-form surfaces. They wanted to make sure they didn't have to go recreate that geometry in the detailed design phase. Another way to think about concept design was this big metric I had around all these customers that were wasting time recreating 2D sketches in the design environment. There's a lot of customers that we surveyed. They'd say, hey, we still do concept design in 2D. There's a degree of design and engineering done in 2D before we mature those concepts in 2D into 3D geometry. And we'd like to be able to do a job better there. I liked Chad's summary because he talked about the fact that, you know, some customers are looking for pure drafting, very, very free form, very easy to get in and out and make changes without any concern about constraints. And some customers want something that's more constrained in 2D, and there's some interesting parallels with direct modeling and parametric modeling there. And our research actually confirmed that. In fact, what we found is customers want a natural progression from something that's as simple and free form as a drafting tool to something that's partially or even fully constrained into the world of 3D. They want that natural progression. And so customers have said, look, we want this 2D design environment with this full flexibility. We want to be able to collaboratively work with the engineer that's working in 3D or work with the 3D design environment. But again, we've got to be able to reuse that information. That information has got to be completely reusable. So the last leg of this stool is kind of the last topic I talked about with the metrics, and that is, you know, repurposing your existing designs with to make new designs. And they're actually, you know, the most common way to think about this is to use 3D direct modeling to do that, to treat the model as if there's no history in the model whatsoever, and actually to manipulate the geometry of the model directly without any concern for the model history, and build new concepts with a much more flexible design process. And direct modeling is really excellent for that, and more of our customers are wanting to use that type of methodology to repurpose their existing designs, even if they started as parametric models and they're perfectly good parametric models. The new concept that they need to create just may not have been anticipated in the original design intent of that model, and direct modeling is a way to bypass that and be able to do that much more freely. And so this design flexibility can lead to tremendous gains in productivity in the concept phase, but they didn't want to throw away their existing design intent. They liked it. They wanted to be able to manipulate their models, but they didn't want to necessarily throw away existing design intent. So that's a challenge for us in the industry to try to maintain that the best we can. And last but not least, something we've been seeing more recently is the customers that use parametric modeling and love parametric modeling, they're saying, what about us? We'd like to be more flexible and more creative, and we'd like to be more efficient with building concepts right in the parametric modeling tool, and what can you do for us as well? So we're seeing that as well. It's some customers love their parametric modeling and want to be more productive making concepts as well, and so that's also something to consider. So I think that's my summary of direct modeling technologies as they relate to the concept design phase, and I think now I'm gonna hand it on further back to Barb for the next introduction, right?
Thanks so much, Brian. I appreciate it. All right, next up we have Dan Staples, who is Vice President of Solid Edge Product Development at Siemens PLM Software. Dan has more than 25 years of experience in the mechanical CAD industry, including key roles at Intergraph, Sensible Technologies, and UGS. Dan was instrumental in defining the original vision for the Solid Edge product line, managing its deployment and evolution, and continues to define the vision for the future of Solid Edge. Dan, take it away.
All right. Thanks, Barb and everyone. So before I got started into this, I wanted to make a terminology clarification. I'm not saying this is the right way to define it. I'm just saying that in this particular seminar, it's been talked about the difference between history-based modeling and direct modeling. And so for purposes of the discussion we're having today, if you'd ask people direct modeling, what do you mean by that, and ask 10 different people, you'd probably get 10 different answers. So let me just explain how we're talking about it today. And that is that we're equating it to no history tree and therefore no expensive regeneration. And I think it's important to understand this because much as all of us would like to just use our CAD system, if you're out there looking at alternatives, you need to be slightly educated CAD consumer, and hopefully that's one of the reasons you're on the seminar today. And so I want to talk about things that are direct but are not direct modeling, and so I kind of have distinguished this as direct interaction. So you'll see this first technology that I'm, for lack of a better term, just calling face location override. And the industry, including Solid Edge and others, have been doing this for 10 or more years. That's the notion that, hey, I have this history-based model, and I want to move this face, and I can do so, but doing so adds another feature to the tree. And this can be handy in certain situations, but for our purposes today, we're not calling that direct modeling because there is still a history tree involved. And of course, the downside to that is as you move more and more faces, your tree gets more and more complex, and that's certainly not the goal. The goal is to simplify things. The other one, and this is really rather clever, and I must say I think props go probably to Autodesk here. I think they might have done this first back maybe again 10 years ago, 8 or 10 years ago. And that's this redirection to sketch. So I say I want to move this face, and the system finds for me the sketch that underlies that face because, as Chad mentioned, it's all about the sketch and it driving the downstream features. And it modifies that sketch, and then it runs the whole history tree. And it looks rather neat, and it is convenient, but it's certainly expensive in large models because, again, this is a history-based technique that is simply using a direct interaction paradigm. So I'm not saying these aren't useful concepts, derived by creative people at various points in the life cycle of CAD. But I don't think they get you the simplicity of direct modeling because they're still history-based techniques that happen to be direct in their interaction. So I just want to make that clarification before I dig in to too much more detail here. So if you think about then, though, if you think about the two paradigms that we're talking about here, let's call them direct modeling or history-less modeling or history-free modeling and history-based modeling. Let's start with history-based. And let me describe this chart briefly for you so you kind of have the context. If you think about the things on the outside of the chart, on the far right or far left as less desirable characteristics, and you think about the things in the middle as more desirable, we can look at history-based modeling and understand that it has some very, very good things about it. And it has some not so good things about it. The things that are good and therefore more towards the middle are that it's highly automated. We all have seen the demonstration. You change one dimension and many things happen. That's a brilliant idea, been around for a long time. It's very dimension driven. Engineers, designers like to think in dimensions, and I want to change this from 3 to 3.2, and that's a good thing. It's very feature based. You have holes and chamfers and thin walls or shells, so that's all goodness. The not so good pieces, and we had to do soul searching ourselves on this because we've typically in Solid Edge been a history-based modeler up through, I guess, 2008. And the not so good things that I think these have been alluded to a little bit in Brian's portion is that it's not great for design really. It's good for documenting the design once you're done, but it requires a certain amount of pre-planning to build a robust history tree, and therefore it's hard to change because you edit it as it was created, which is what I think Chad referred to. We call that edit as created. And I'm sure all of you know, particularly those of you working on more complicated parts, that it scales poorly. Once you get a couple hundred features or 1,000 features, it gets pretty ugly. And then the other aspect is it's indirect, and we all kind of take this for granted, but we say if you're a history-based guy, edit the sketch and it will update the part. Well, that actually is a very indirect way of going about things. You want to move a face rather than move the line that implied the face. So good stuff and not so good stuff. If we then think about the other end of the spectrum, history-free modeling, and this is a technology that's come a very long ways in the last 5 years, I would say 5 to 8 years. But typically what it's very good at, or it brings to the table in the more desirable characteristics, are that it scales very well because it doesn't have to do the regeneration. It's very flexible because it's not only edit as created, and it is very direct. You interact with the faces, so you're not indirected through sketches, so that's all good. As we personally took a look at this in building sort of our next generation of technology, the things that weren't so good about it were that it's featureless, so it's less feature-oriented, and it's less automated and less dimension-oriented. So some systems had taken a stab at putting more dimensional aspects in, but they tended to be a bit fragile. And I will say this area has come a long ways since we looked at it 8 or so years ago. But it certainly, those are the typical downsides associated with direct modeling. So I think what I'd like to say is that it's not necessary to choose, and I think it's unfortunate that people have to choose. So I don't think anyone wants to say, well, I do this kind of work, therefore I'm going to do direct modeling, or I do this kind of work, so I'm going to do history-based. Because as we saw, they both have their beautiful parts and they both have their warts. And so the goal really, it's incumbent upon us as an industry to deliver to you a more optimal solution that takes the best of both worlds. And so obviously this is something me and my team embarked on long ago, and I know others in the industry have worked on this issue as well. The goal is to say, well, gee, why can't we have a highly automated, dimension-driven, feature-based system that scales well and is flexible and direct? And the answer is you absolutely can. It just takes tens of millions of dollars of investment on the part of the CAD vendors to achieve that for you. And so the reason I point this out, I guess, is that there is kind of this best of both worlds. It does exist. I don't think you as users have to choose, but you do need to be that somewhat educated consumer and dig beyond the surface of what you might see in a demo or whatever and figure out, is this system really solving these problems in a cohesive way in a single file with a single application? And that's what I would suggest is the state of the art today. Now, in building our version of this, kind of the school of hard knocks thing, and I think this is one of the questions that we're trying to answer is when and why should I use what? And I would say that it's frankly almost a no-brainer these days if you're doing something that does a bunch of machined parts, straight break sheet metal, you're working on really large assemblies. These are just straight up really better done by some form of direct modeling. And if you haven't engaged with that, you should engage with it further, and I think you'll see this for yourself. But then there's other areas. A lot of people don't do just those things. They do some of the things on the left here, casting or plastic parts or whatever. And so I think, let me explain to you at least my thoughts on, when to use what and how to use what. And I've circled here two things. The first is assembly productivity. So let me go there first. One of the things we learned over the years as we built our technology in this area was that we started building it because part modeling was inefficient for certain classes of parts. But what we didn't realize was how much that plays into assembly productivity, and we've learned this since. So I suspect most of the people on this call, whether you came 2 years ago from AutoCAD or 5 years ago from 2D AutoCAD or 20 years ago from 2D AutoCAD, at some point in your past you're probably doing 2D drawing on the CAD system and more than likely using AutoCAD. And back in the day, you could have a complicated assembly design and just do a window select of some of it and use the stretch command. I think it's called stretch command. And you could modify 6, 8, 10, 20 parts at once. And even though you're going to maybe later pay the price downstream because you were working in 2D and interferences and all that, the notion that you could just do that was pretty productive and remarkable. And that's one of the things that direct modeling enables in today's systems, is the ability to say, oh, in 3D I want to move this large collection of faces across many different parts all at once to this new location. And that just is not possible in a history-based system, and don't let anybody tell you otherwise. I think those of us who've worked in history-based systems a lot know that when you edit one part, there's some maybe slightly less than even chance that your history tree is going to break and something bad's going to happen. So when you're editing 20 history trees at once through a fence or a window area drag or something, there's a lot that can go wrong and a lot of fix-up that's going to be required. So it's just not realistic in that kind of system. So again, I would say if you're doing that kind of stuff, a lot of assembly productivity needs, machine parts, straight break sheet metal, straight up direct modeling is good stuff for this. The learning area for us that was interesting is the castings and plastic parts and stamped parts. So I would submit that even though those have a lot of interesting shapes and rounds and draft angles, that you should also not do those direct up in a straight up history system. They are painful and expensive. And what I mean by that is if you go to a part that has a couple hundred or 1,000 features, which these often do, and you regenerate, it's expensive from a time point of view and expensive from a collateral damage point of view. And so, again, I think you should be able to take the best of both worlds. There are the technologies that exist today that say, let's separate out the design aspect from the necessary manufacturing aspects. So if you think about one of the more complicated parts in industry, like a transmission housing, it looks really complicated on the outside, which is, a bunch of rounds and add draft and all that kind of stuff, and that's true. But the functional design has very little to do with that. The functional design is around what fits inside of it, how does it bolt on to the rest of the power transmission, and how does it interface with everything else? How many ribs do you need to keep it structurally sound, and so on? And I would suggest that all that stuff can be done within this blue circle here. All be done parametrically, but with no history tree, dimension-driven, but with no history tree, and be very productive without having all that regeneration and feature failure. But then that aspect that has to do with the manufacturing pieces of getting the draft angles just right and adding all the complicated rounding and the way they interact can be done in the history part of the system. So again, I don't think you ought to have to choose, nor is it right to choose and say, history-based, history-free. You should be able to do a design that has the design basis is history-free, and some of the manufacturing aspects are history-based, and that should all happen within a single piece of software in a single file. And so again, my plea to you, I guess, today is if you you haven't seen this, you need to maybe open your eyes, widen your horizons a little bit to go see that there are systems out here that can do this all in one piece of software and really one technology that blends all this together in a way that's more productive. And so I'd encourage you to just make sure you're opening your eyes wide enough and looking at broad enough horizons. And that closes my remarks. Barb or Chad, whoever wants to take back the discussion.
Okay, excellent, Dan. Thank you so much. Let's move on to the Q&A. Just real quickly, someone has asked if the webinar is being recorded, and as I mentioned in the beginning, it is. The audio is being recorded, and both the audio and PDF of the slides will be available within a couple of days to all those who have registered. So, also, let's, and I don't know who wants to answer this. Maybe you all want to speak on this topic. We did not cover simulation at all, which is obviously an important phase as well in the product development process. Where does direct modeling fit into simulation, or what paradigm best works when you know you're going to have to simulate your model?
Great question. Can I take a stab at that first, guys?
Go right ahead.
Absolutely.
All right. So I think that both technologies fit, but in two very different scenarios. I think with direct modeling, it helps you with simplification and abstraction of the model. Now, if you try and do that through feature-based approaches, you can run into model failures, and you got to find the guy that originally designed it to really make progress there. So direct modeling is a really good fit there if you're looking at one model and you want to get it ready for simulation. However, there are a lot of organizations today that deal with a lot of variants of products or parts, and feature-based modeling is a great way to automate the generation of those variants, and that applies to simulation as well. When you look at things like design of experiment studies, optimizations, and things like that. So I think both have a fit, but very different uses. That's my take. Dan? Brian?
Yeah, I think that's a good take. The only thing I would add to it is that you talked about the abstraction, and I think when you get to that, it's typically the analyst who is, getting something from the designer, and he needs to abstract it for purposes of analysis. And the thing about direct modeling in general is it's, for someone who's not a CAD expert and hasn't been indoctrinated into the history tree and the recipe that most of us got indoctrinated into 10 or 15 years ago, it's much easier to approach direct modeling. It tends to be, those of us who are history-based say history-based is intuitive. Well, that's only because we had it beaten to our heads for many years. But certainly, I think if you were to ask the average guy on the street or the guy who's an analyst and not exposed to CAD on a daily basis in terms of modeling, it's just a lot easier to approach the kind of changes he needs to make by doing direct modeling.
Yeah, this is Brian. I would only add that it's not merely a matter of direct modeling style changes for purposes of abstraction or for purposes of simplification, but it's also, the analyst does his first round analysis, he gets a result, and he realizes, well, I've got an issue with the stress here or there, and the analyst then wants to go in and modify the geometry, not for simplification or abstraction purposes, but because he's got a stress problem, and he could go through the pain of going back and asking the engineer to make that change, or he could maybe do some exploratory work with the model himself, not needing to worry about the original design intent of the model, and can make direct modeling based changes to the model in order to explore how to reduce the stress or how to change the natural frequency or whatever type of analysis you're doing, in order to achieve the design goal without having to cycle back through the person who understood the original design intent of the model. So it's lots of good reasons there.
Yep, I'm exactly on that same page.
Yeah.
Okay. All right. Thanks. The next question is, how do you get around the fact that most designers will not go back to define the model after initial creation? Not directing this at anyone in particular, whoever wants to take a stab.
What was the question again? Can you repeat it? I'm sorry.
How do you get around the fact that most designers will not go back to define the model after initial creation?
So I'd take a stab at that, because that's my point of view is you absolutely shouldn't have to. That the point of concept design is to be very fluid, try out a bunch of things. I often say that design is not a linear process. It's very non-linear, and you go down a bunch of blind alleys before you get where you're going. And that's not only true at the very concept phase. As you get into more detailed design, it's true. So I think you absolutely need to be able to take the concept design as it may exist, be able to further refine it, continuing to use these direct techniques, and ultimately produce it using the same direct techniques, and maybe adding a few history-based features at the end if you'd like to, all in the same file. I think it's fundamentally not right to presume that I must do concept design in a direct way and then, stop and redo it in a history-based way. I think that's just a fundamentally incorrect assumption on a lot of people's parts.
Okay, thanks, Dan. The next question is, can you please explain dimension-driven editing?
Sure.
Yeah, so I guess I'll take that one. I think well, actually, maybe we should have Chad do that one because I think it was on his slide. Chad, you want to maybe you should
Sure.
take
Yeah, sure. So I think I think this is where there's a little bit of a misnomer in the market today. So, history-based modeling has always, well, not always, I guess, but traditionally has been parametrically driven, right? So you can define a dimension for the length or width or height of a sketch in an extrusion and the depth of that extrusion, and you can modify it, right? You can make changes to the geometry that way. And for some reason, that approach really got ingrained with feature-based modeling, history-based modeling. And there's this perception that you can't use parameters or dimensions to make changes for direct modeling changes. And actually, that's not true. I think what you find is a lot less dimensions in direct modeling models created with direct approaches, but you can still use them to move sets of geometry. So that's my definition. I think they apply to both. Anybody else?
Yeah, I think that's accurate. The difference is that the question of whether dimensioning sketch entities that then ultimately drive 3D entities, that's the history-based way, or whether the dimension is between two faces that don't have a sketch associated with them. So it can all be dimensional. It's just a question of whether it's driving the sketch, which in turn drives the faces, or the dimensions directly driving the faces themselves.
Okay, thank you. Our next question is, can you talk about the different approaches, and I assume he means modeling approaches, to be used when he's using the term foreign data, but he's meaning data from other CAD systems is loaded when you're working with other CAD data, meaning models that are created in a different CAD system.
Right.
Yeah, well, I mean, I guess I'll take a stab at that. This is Brian. Sure. I mean, it's pretty obvious. I mean, that data interoperability between CAD systems has been it's been tried at the feature level. It's generally not all that successful, at least not in a robust way. And so generally, when you take data in from another CAD system, you're going to get information like assembly structure, and you might get as much information as part color. But for the geometry, you're going to get just a closed volume, assuming that the data translation for the BREP geometry came across well. And so direct modeling tools are, I mean, unless you want to just use your own history-based features to cut geometry out and recreate it from scratch, direct modeling tools are an ideal set of tools to manipulate geometry that's come in from a CAD system and in which you don't have the features any longer. I mean, it's a pretty nice approach to be able to move faces, to align faces, to resize analytic geometry. There's lots of to symmetrically change a model if it looks like it might be symmetric. There's lots of tools built into most direct modeling environments that will give you great control over geometry, regardless of the fact that geometry had no features when it came over. You can actually use direct modeling tools to really control that geometry in pretty sophisticated ways, despite the fact that when you got it, you didn't get any features at all.
Yeah, I would just add that I don't think it's to be honest any contest. If you were to be reading in data from another system, and you could choose to read it into the history-based environment or the non-history-based environment, definitely read it into the non-history-based environment. You have much more flexibility and ability to make the changes you want to make. And I would suggest that that's, in fact, if you're a die-hard history-based user, but your system supports a non-history sort of mode, that this is where you toe dip yourself into it. Certainly we've seen our users who, when they want to get started with, in our case, synchronous technology, and, do I want to use it, do I not want to use it? Well, by gosh, the first place to use is with that imported data. That it's definitely a home run there.
Yep. Agreed.
Okay, great. Thank you. Is direct modeling incorporating more Boolean operations than was done in the past?
I guess my perspective is not incorporating more Boolean operations or less. It's just a question of what you choose to do with it afterwards. So for those who aren't familiar with that term, Boolean operation is kind of a mathematical term that means, you difference out some material or you add some material. And I mean, that's the essence of feature-based modeling and how one creates 3D design. We don't call it Booleans anymore. We call it feature-based modeling, but that's what happens under the covers. And the only question is, when you're done, saying place whole, has it added another feature to a linear regeneration history tree, or has it simply modified the body and you now have that hole in the body, but you don't have, the expense of the linear tree?
I think it's possible that the question was asked mainly from the standpoint of, hey, I want to take some geometry from some model and use that as a template to either to maybe remove a profile of this same geometry from another model, and it sounds like the question was asked from the standpoint of maybe they're not seeing all those types of tools in all direct modeling environments. And I guess I would say that a full set of Boolean capabilities is kind of necessary, and in any mature direct modeling system, they would be there. Would you agree, Dan?
Oh yeah, absolutely, no question.
Yeah.
All right. Our next question is, any suggestions on how to handle the change of behavior required to move from the history-based parametric modeling approach to these new approaches?
That's a great question.
I think, okay, go ahead, Brian.
No, I was actually Chad, I think, that was going to speak up there.
Oh, Chad.
Yeah.
I can't tell everybody apart on the phone.
So I think the one change in behavior that has to happen is, I just compare it with history-based approaches. People have, in the past, they've been so careful about how they build, either they're so careful about how they build up their model so that it can be reused, that it can take longer than really required, or people don't really take care and they create these unstable models. I think I think the direct modeling tools can actually make for lazier modeling, and I mean that in a good way. You don't get paid to create the perfect feature-based 3D model. You get paid to come up with a great design and document it and pass it on. And I think that in that regard, direct modeling can support that approach.
I guess my experience is that a couple things. The first is to be open. So the biggest problem we typically see is that either someone is successful or fails at adopting direct modeling techniques based on the openness of their mind. If they, are so tied into history that they can't open their mind that there might be a better way to do it, those people typically aren't successful. The people who are successful are the ones who say, this looks interesting, I'm going to try it, and I'm going to fail for the first week or so because it's so different to me, but I'm going to persist. And so to me, openness is the number one thing. And then I think the other thing is, and it's kind of related, you have to be open to changing your thought process. So the first thing that's uncomfortable to people is that when you create a sketch and then it's extruded and the faces are all there, you really don't need the sketch anymore. But it's hard to let go of it. It's like when you're learning to ice skate or ride your bike and you don't want to, let go of that concept. And sooner or later, it varies by the individual and their openness, once you kind of let go to the fact that, hey, the faces are already there, the dimensions still exist, they're just the faces, I don't need the sketch to make changes, and you start to make progress. So I think openness and willingness to change is the number one thing.
I would add that it's useful to think about adopting direct modeling first. If you're a company that has traditionally, built your design processes with history-based modeling in mind, it's useful to think about adopting it from the standpoint of maybe a couple key use cases where you're just having trouble with your history-based models, that whether it's for simplification purposes or whether it's for concept design or maybe even for detailed design of certain types of parts. And Dan highlighted some areas where it can be helpful. Maybe you sort of treat the necessity of being more efficient in certain areas of your development process as a good reason to be motivated to have that diligence to stay with it, as Dan suggests. Build it around a business case with your management that we have the opportunity to improve our efficiency in concept design, or our efficiency in designing certain types of parts, or our efficiency in dealing with simplifying models for simulation, or what have you, and go and learn the tool with the motivation to improve that process, and maybe with a specific business process in mind that you want to improve, you'll be more likely to stick with it and have something demonstrable for your management that you can go to them and say, look, we saved this amount of time by using direct modeling technology to improve this particular part of our design process.
Okay, great, thank you. That was a great question. All right, next question. Product design is somewhat different from tool design. How does a non-history-based approach work with a tooling assembly consisting of many components? And he's thinking of progressive dies, molds, and automation machines. Anyone?
Well, we're all quiet.
I know, so you're pondering, that's good.
So specifically around like progressive, well, in general, I think for tool and die design, direct modeling is a really good fit. And the reason why it's a really good fit is because you want to take existing geometry and do subtractions from a block and split it and all that type of thing. And then you need to make small tweaks to the tooling geometry. So I think it's a great fit there. Now, the only caveat is, especially with progressive dies, with sheet metal, you need to turn the sheet metal part. You need to take steps backwards to a flat sheet, right? And that may lend itself more towards a history-based approach because you're looking at a sequence of representations of that part as it progresses through that progressive die. So there might be a fit. I haven't seen too many use cases, but that might be one where history-based is a good fit.
So I would say I'm not deep on the subject myself. This is Dan, but I know that one of our very first synchronous adopters, it's a huge progressive die shop, and they love and swear by it. So if whoever asks that question wants to just drop me an email, I'll try to get you in touch.
Yeah, I mean, this is Brian. I would add that generally, if you can, the CAD user in a tool design shop that's designing tooling all day long, and if the parts are built in such a way, especially if it's progressive die, if the parts are built in such a way that the fold up of the part is reflective of how the fold up might work in the progressive die tooling, there can be lots of leverage there. I've seen that in parametric based tool design shops, but it really comes down to, I think, just like in the design phase, there's a preference. There's certain areas where in tool design where it might be better to use direct modeling versus parametric modeling. I've seen both, and we've gotten questions, at PTC in how to better apply both technologies in tool design. I think it can be done. It can be done either way.
All right, great, thank you. Brian, I believe this question is directed at you, but I will welcome either Dan or Chad to pipe in as well. The question is, the survey said that most companies want to reuse concept designs in detailed design stage. Wouldn't that always prohibit using direct modeling in the concept stage?
it doesn't, and the reason that I say that it doesn't is because of some of the points we made about history free models being continuously modified in detailed design, and about history free modeling still not necessarily meaning dimension free modeling. As you look more at direct modeling technologies and how they're evolving and how they're maturing, you can impart design intent on a model that's largely history free and still control certain key aspects of the interfaces of that model and key design aspects of that model with constraints and with other types of technologies. It is possible to mix the two, as Dan has said. I mean, he was right in saying that in many models there is 20% or less of the faces that are absolutely critical to control the design intent of the model, and the rest of the faces, if the geometry is there and the geometry is right, it's okay. It's going to do the job. And what we're finding is that customers can, in fact, mature designs from 3D that have no history, whether they came in from a third party or they were using strict direct modeling from the front end, and mature them into real production models down the path without having to recreate that model from scratch using history-based designs. I think that's a waste of time. We wouldn't encourage that, and I'm sure Dan would agree.
Yeah, I would. I think whereas what we've said is that history-free or direct modeling can be excellent for concept design, should not then therefore equate that therefore it is for concept design only.
Right.
It is absolutely for heavy-duty 24/7 engineering and design work, and so don't be fooled by thinking it's not. It definitely is. In fact, it's a very strong point there as well.
Yeah, I think only customers that have only used the history-based parametric modeling approach in their business are having, they're just getting warmed up to this concept. But both Dan and I have thousands of customers that rely solely on direct modeling every day for everything they do, absolutely everything they do, and it can be very, very simple products or very, very complex, highly engineered products with tens of thousands of parts in the assembly. There really is no limit. It's all a matter of the company deciding what set of tools suit their needs best.
All right, thank you. Our next question is, what is the role or definition of associativity in the direct modeling domain?
Interesting.
Broad question.
Yeah. So I could take a stab at it. I mean, to me, the word associativity is often equated with parametrics and such. The notion that changing one thing changes other things. They're associative. They're whatever. So at least that's the way I typically interpret the word, or we've used it in the past. So again, I would just come back around to the fact that things can be related to one another, and things can be dimensionally driven, and therefore, association between the dimension and the faces. The key difference is that it doesn't cause a linear regeneration of the tree top to bottom. That's the expensive piece, is edit the first feature, pay for all subsequent 1,000 features, and that's not true in a direct modeling system. But that notion of associativity, meaning that things can happen, dimensions are edited and faces move, or face A is concentric with face B, and therefore it should move also. That's associativity by my definition, and is perfectly valid in a direct modeling system.
Agree. Couldn't have said it better myself. It's totally
All
true.
right.
Direct modeling doesn't exclude associativity really in any way.
Hey, Barb. So I think there's probably a finer point here, which is there's associativity between there's design associativity and there's deliverable associativity. So you might want to have design intent, because of design intent, have a change ripple across multiple parts in the same assembly. You might want to have, well, obviously, when you change a part, you want the drawing to update. You want a service assembly animation to update. And I think in both of those cases, I mean, that neither are really limited by direct modeling.
Correct.
Right.
I think
Agreed.
they're separable.
Yeah, I mean, maybe another way to look at it is when you're building in a history-based parametric modeling system, every selection that you make of some other geometry to create a dimension or to lay down a line in a sketch or whatever it may be, it does create an associativity that you as an engineer, you have to consider, is that an important thing? Is that aspect important to my design intent? And if it is, that can be a very powerful thing, and they're inherent in the design process. Whereas with direct modeling, I would say that kind of thing is very much put in, right at the top of mind of the engineer as they're working through the direct modeling process. They will put that in into the design as they see fit. It just doesn't happen naturally. It's something that the design engineer consciously decides, I want to create this associativity. It just doesn't happen as a natural part of the design process. Whereas with history-based systems, it very much is ingrained. Selections that you make do in fact create associative references, unless you specifically say, no, I don't want that. It's usually the opposite assumption in direct modeling.
All right, great, thank you. Next question. When moving from the concept phase to the documentation phase, how does direct modeling compare to history-based modeling from a time perspective, given that a good percentage of dimensions will be automatically generated within the history-based model?
Yeah, I don't know how it works in all systems, but certainly what we're familiar with is, in a history-based system, the dimensions are in the sketches, and then those are retrieved into the drawing. In a direct modeling system, or at least in Solid Edge, let's say, in synchronous technology, the dimensions take the form of what we call PMI, product manufacturing information, or the 3D dimensions that are on the faces of the model instead of in the sketches. That doesn't change the ability to retrieve those into the drawing. So, the fact that they're on the faces instead of the sketches, same thing in terms of ability to retrieve those into the drawing and use them without having to recreate them.
Yeah, I think if you have good workflows for creating or showing those dimensions in the 2D context, it could be similar in terms of efficiency to do either. I don't see one strongly standing out. There's good efficient workflows for creating dimensions on models that have no underlying sketches, and there's good workflows for showing them on models that do. And as Dan and I have said, dimensions in the direct modeling environment can in fact still drive geometry if the user tells the system that's what he wants. And so you can still even get that behavior, maybe not to the level you would get with a large feature-based, history-based parametric model, but you can still get that behavior. So I could say that in most circumstances, there may be some circumstances where one is slightly better than the other, but I'd say it's fairly close in terms of efficiency to sort of create that documentation. Would you agree, Dan?
I would actually say it's somewhat more efficient. One of the constraints we forget about is that when you build up a history-based model, you build it up sketch by sketch by sketch. That's not necessarily a natural way to dimension the part. In fact, it's pretty bad practice in terms of a dimensioning scheme because you tend to have a lot more dimensional stack-ups than you would like. Whereas if you're in a direct modeler, you can put in dimension between two faces on the model that are far from each other, and there's 50 features in between. And so you can actually have a much more natural dimensioning scheme that's more immediately usable on the drawing when using direct modeling, in my opinion.
Yeah, I think we'll agree there that bad modeling technique in your history-based parametric modeling will make it even harder on in the drawing mode to do that. If you've got a good, well done history tree, then maybe it's not as hard. But it's a good point.
All right, thank you. Next question. What shortcomings does direct modeling have with respect to rules or constraining assembly features?
Let's see.
Well,
so I can take a stab at what we do. I don't know what other folks do, so maybe Brian wants to chime in afterwards. And in Solid Edge, we've chosen for assembly features to actually, because they are process-oriented features, assuming you mean by assembly features what we mean, so I better start there. To me, an assembly feature is I put two parts together, and then because of the manufacturing process, I need to machine a feature in the context of the assembly that modifies both parts simultaneously and doesn't change the original parts that exist on disk. So it exists only in the context of that assembly. In our mind, that is a manufacturing process, and is actually best served by what we call ordered features, features that have an order or history-based. So in our context, the assembly features do, in fact, have sort of a history basis, even though we call it ordered, because we think it matches the manufacturing process appropriately.
But there's nothing about the design paradigm, parametric, history-based versus direct, that makes it any more or less difficult to sort of create that, as long as the system can understand that this geometry aspect exists in this context but not in that context. As long as the system has the capability of understanding that, there's no reason why direct modeling or history-based modeling that choice would dictate whether you could accommodate that type of thing in your designs, right?
Yeah, I think the only caveat maybe would be with design intent. Excuse me. So, you know, that whole dam that you just talked about, if you do want that to persist down into the part, so if you're using a feature-based approach and you create the whole at the assembly level, it modifies both parts, and then you make a change, that change will associatively be reflected in both of the parts as well. If you go with a direct modeling approach, I guess you would have to select all of the geometry in both parts in the assembly to make the modification. But there's no, I guess it's more of a manual type of activity as opposed to using a feature, which there's one definition, it knows it goes through both parts. So
I don't know that that's exactly true, though, because certainly you can have a and I guess I was speaking specifically to assembly features that don't show up, therefore, in the component parts because they're, you know, it's a whole different part number after assembled. The ones where it's pushed down into the part are, I think we call them assembly-driven part features. That certainly you could either choose to do that in a history-based way or in a direct modeling way, and they would both result in very similar editable associative thing.
Got it.
Thank you. Oh, I'm sorry. Chad, did you want to add something?
Nope.
Okay. You guys all have education programs with your software. This is kind of addressing that. How is the response been of engineering undergraduate professors and students to learning direct modeling approaches?
You want to go first there, Brian?
Actually, I was just thinking. I really don't know. I wish I could give you a good answer there. I know that we offer our parametric modeling as well as our direct modeling tools to universities and schools, but I haven't heard specific feedback on the direct modeling paradigm. I just sorry, I don't have a good answer for that one.
I guess I would just add that it seems to vary somewhat by universities. You know, some want to teach history-based because that's what, you know, the industry's been used to over the years. Some are more progressive and feel that it's easier to let their students focus on engineering as opposed to, you know, CAD minutia. If they do direct modeling, it is easier for someone who hasn't studied history-based to pick up. And in fact, we have a really interesting case out at, I think it's Utah State, where they've taken the engineering and the art program and been able to merge the two to create these vastly unusual shapes and designs really that are only enabled by having direct modeling, and you just wouldn't really even try to approach that in a history-based system, nor did the art department have any interest in learning how to navigate a history tree. So I do think there's some new opportunities there.
Okay, great, thank you. Next question is, can I currently investigate products that have married direct history-based modeling with allowing to convert from one to the other? That means without.
Well, certainly, you know, if you want to investigate that from, you know, I guess you're talking about individual products. You can certainly investigate that with Solid Edge. We have a free trial, and you're welcome to download it and, you know, use it for 45 days and try out the integrated aspects of it. I'm sure others, you know, offer an ability to look at that as well.
Mm-hmm.
Yeah, sure. Same thing with PTC. Go right ahead. We have both types of tools available for you, and an integrated tool available as well. So it's a matter of reaching out to ptc.com and going through the process.
All right. One more question. How accurate are the direct models compared to feature-based models?
Well, they have the, at least from my perspective, which I think represents the industry, they have the exact same accuracy. They're typically based on a deep parametric or geometric kernel, Parasolid or Granite from PTC. These go down to, generally speaking, 10 to the -8 or 10 to the -10 precision, and whether, again, the notion is really, is there a linear regenerated history tree out the back end or not? The final model has the same precision regardless of which tool you use.
Agreed. There's no reason for there to be any difference. Both could be highly accurate.
Okay, excellent. All right. I think that completes all the questions. Any last-minute comments from any of the speakers?
I'd just like to thank you and PTC for getting this together. It's always my hope that we have very informed consumers, and I saw we had a bunch of folks on the call, and I hope they're better informed, so I just really appreciate the time.
Absolutely, and thanks everyone for joining us. Just as a reminder, the PDFs of the slides will be available, as well as an audio recording of today's webinar will be available within a few days. We appreciate your time, and as always, connect with us on designworld.com as well as 3dcadworld.com. And if you'd like to join in a discussion of this webinar, you can discuss this at engineeringexchange.com. So thank you everyone for your time, and thank you speakers for your time as well. I appreciate it.
Thanks, Barb.
All right, thank you.
Yeah, thanks, Barb. Thanks, Chad. Brian.